I think this is completely your field to go ham. Like, so what is cryptography, and like, why do we need it? What are the uses and applications for it in today's world, especially with everyone heavily depending on these devices and these computers? What is it, and why is it important?
So in terms of why is it important, I mean, if you do online banking, I'm afraid of it, but if you do online banking, you're also betting all your money on it. So if you ask how important is it to you, well, you just look at the money in your bank account. That's how important it is to you. So I like to talk about the ways people use cryptography by just telling a little story. You come home one day, you have a wireless network in your home. So you come home and you take your phone out of your pocket, and you maybe send something to a printer, and you maybe upload or download stuff from some home computers that are on the network. And then you go to your bank's website or app, and you do some banking. And you used a huge amount of cryptography in doing that. And there are, in particular, there are 3 different algorithms you used, and those algorithms have certain security requirements. And if you like, I can talk about what those security algorithms are.
For sure. Absolutely.
But you've certainly used a lot of cryptography there. And there are other things people use cryptography for. I think that story I just described takes into account, at the moment, most of it. In the future, there may be lots of other things. And the things I'm talking about also are used in blockchain, although not everybody does blockchain stuff. But everybody does the things I just described. So, and so what's going on there? So we can talk about that if you want, but I think it's a nice thing because we're all using it all the time. So at the core of all of this, I think, is something called a secure session protocol.
Okay.
Which here's, this doesn't have directly to do with what I just talked about, but it is there, but it's hidden. If you and I are together right now, but we want to have a conversation over the internet in a few days, so we might get together, flip some coins, and choose a long random key, and then when we're apart, we'll use that random key to have the secure conversation over the internet. And I call that a secure session protocol. Okay. And that's part of what the standard called TLS, but I call it a secure session protocol. And we're basically encrypting stuff back and forth to each other. And we want it to have certain properties. The 2 properties we typically talk about are privacy and security. Privacy and integrity. Security consists of privacy and integrity. But against whom? I mean, who's the bad guy here? And one of the nice things about this field is if you want strong enough security, you're assuming a very strong adversary. And the adversary I'm assuming here is someone who has complete control over the internet. And one of the beautiful things about securing against someone who has complete control over the internet is you don't have to understand anything about the internet. In fact, you're better off if you don't, because you'll make assumptions which aren't true, because the internet is whatever the bad guy wants it to be. So, for example, in order for the internet to work in the absence of a bad guy, you have to understand the internet. So the people who wrote up all these algorithms that allow you and I to do what we're doing now, talking over Zoom, etc., that's all very, very clever and complicated stuff. But we don't have to worry about any of that because the adversary now controls the horizontal and the vertical. That's an Outer Limits television reference. The adversary controls everything. So what do we want him not to be able to do? We want to have privacy against him and integrity against him. Privacy means he can't learn anything about what we're talking about. It's more complicated than that, but that's the basic idea. Integrity means he can't change what we're talking about. That is, he can't make you think I'm saying something different than I am, or make me think you're saying something different than you are. And now some people might say, well, wait a minute, can't he just put garbage on the line? Can't he just cut the wires? And the answer is yes. The disadvantage of hypothesizing a strong adversary is you can't stop him from doing that, but you can stop him from learning about our conversation or learning or changing it. That is, if he cuts the wire or throws garbage, one of us will say, this is garbage, and we'll have to somehow start over. That's a separate issue, how to start over. But he shouldn't be able to break integrity or privacy.